All right. I'm hoping you've seen the screen being shared, a reminder about parts of the circle. Are we seeing that?
Yes, sir.
Okay. So quickly, I just want to scroll to that. And the first big word we see come across is a diameter. And this is very important to us because there is a theorem linked to this. And the theorem we normally refer to is the angle in a semicircle, which means that your diameter will produce a right angle on the circumference. Half the diameter is a radius. Very important concept because we have theorems that come out which tells us that the radius is perpendicular to a tangent. We'll come to that a little later. So we talk about a minor segment, a major segment. Basically, a chord divides a circle into two segments. And then you see the blue lines is what we want to point out of a tangent, which touches the circle once. And remember our famous tan-chord theorem. Okay, so we need to get it thinking right with geometry. There are keywords that will come out in a question in geometry. Now, I just want to start off with some keywords. So the first word I want to talk is about center. So if you see the word center, can you tell me some of the theorems you know which pertains or links to a center?
The angle at the center is 2 times the angle at the circumference. Yeah?
Okay, let's do that very quickly. Let's get a rough picture of what you're trying to tell me. I hope you're drawing on a page there. So we have a center. And if we produce that, we are saying that the angle at the center is twice angle at the circumference. Are we happy with that? Yes, no? Very important to note, the angle at the center is formed from the two blue points. You can call it a chord if you want. And from those two same points, you have an angle at the circumference. Any other theorem? Center. Only one?
So is the one a line going straight to the center, sir, and if it touches the circumference, one of those angles is equal to 90, sir, or the angle at the circumference.
Okay, let's get the theorem. What is the name of the theorem that you're going to use as a reason? Angle in the semicircle. So what you're trying to tell me, young man, and you're right. If we have a center, a line going through, that becomes a diameter. And this produces an angle at the circumference, which is 90 degrees. So this we call the angle in a semicircle. So angle at center, angle in the semicircle. And why we have associated this with this with center is because your diameter has to pass to the center. Anything else with the center? Only two theorems the grade 11 students of 2022 know associated with center. That's quite sad, actually. Come on.
Line from center to midpoint on chord, or line from center perpendicular to chord.
Chord theorem, the famous chord theorem. A line from the center, if it's perpendicular to the chord, then it bisects the chord. Okay? And the converse of that as well. So only have three theorems.
So there's also tan perpendicular radius.
Well done. I'll put that one. From the center, we have a radius, and it's perpendicular to a tangent. And this may be very simple what I'm doing, but when we get into a question, when you see the word center, very quickly all these theorems need to be coming to your brain. If it doesn't, then you're not going to be able to solve the problem. Okay, so let's take another word. Are you all happy? Have I missed out anything? Also with the center, it's very important to understand, not a theorem, but if I have a center, which I'm going to draw now, that's my center. You'll notice that we have radii, and your radii will always be equal. And normally this will produce what we call an isosceles triangle. So look out for that as well when you have a center. So your radii producing an isosceles triangle. Okay, so that was a good word, center. I like that word because from that word I was able to pull out at least 4 to 5 theorems there. Let's take another word. Okay, another word I'd like to look at now is something called a cyclic quad. So if you see this word cyclic quad, what do you understand by that?
Opposite angles of a cyclic quad equal 180 degrees.
Okay, before I go there, what is a cyclic quad?
So it's a quad that fits in a circle. All,
4
all-
points touch
all
the
the
circle,
points-
okay?
Yes, sir.
4 points must touch the circle. We have a cyclic quad. And someone says very nicely, if that's x, that's 180 minus x. And the reason is opposite angles of a cyclic quad are supplementary. So we got one theorem. Anything else with the cyclic quad?
Angles in the same segment, sir.
Angles in the same segment. No, we're talking about a cyclic quad, young man.
So is that not one of the reasons to prove a cyclic quad?
Well, there's lots of reasons to prove something a cyclic quad, but I just want to look at this word cyclic quad. I want another theorem associated with a cyclic quad.
So exterior angles of a cyclic quad is equal to the opposite interior angle.
Well done. The exterior angle of a cyclic quad, as you can see, will be equal to the interior opposite. So if we're looking at this point here, so your exterior angle, which means the outside angle, will be equal to the angle opposite. So a cyclic quad, and they use a big word called concyclic. When they say concyclic, it means that the 4 points touch the circle, or a circle passes around those 4 points. Okay, I'm quite happy with that word cyclic quad. I want to take another word before we get into some questions. And the word I'm looking for is called a tangent. So if you see this word tangent, give me some theorems you know about tangents.
Tan chord theorem, sir.
Oh, the famous tan chord theorem. See, I haven't talk about this as being our famous tan chord. So let's apply this. The angle between, here's our tangent. Can you see that? So it says the angle between a tangent and a chord. So we need to construct a chord. So the angle between the tangent and a chord will be equal to the angle in the alternate segment, subtended by the same chord. So let's draw that in. So from that same chord, any point on the circumference, it means that that angle on the circumference, can you see that? Because it's produced by the same chord. So that's our tan chord. And remember, on the other side, we also have an angle. Don't miss that. So if we call this y, then from this chord, opposite will give us y there. So there's our tan chord theorem. Okay, another theorem associated with the tangent.
So there's the one where the tangents form equal angles. So like it's like an isosceles triangle.
Hey, you can't write all that. You guys write in geometry on Monday, you don't know the proper reasons. You have to pin it down. What are you going to say? What will your reason be?
Tangent
Can't
from the
say
same
in
point.
geometry, this something, that's something, or no, you got to have a concise reason. You should know your reasons by now. Okay. So what you're trying to tell me, if I'm right or wrong, is 2 tangents from a common point. Yes or no? Is that what you're trying to tell me?
Yeah,
2
that's the one. So
tangents, yeah, 2 tangents. So we remember the reasons now. two tangents from a common point. And what's important to note, that will produce an isosceles triangle. So two tangents from a common point are equal. And then we discussed this earlier, so let's quickly put that down. A radius is also perpendicular to a tangent. Okay. And also if it was a diameter, remember if it's a diameter, half the diameter is actually a radius. So diameter is also perpendicular to a tangent. Same concept, okay? I think we've covered some key words, and what we missed out is a theorem called angles in the same segment. Have you done that one? Angles in the same segment are equal. Am I right? Have you heard of that one?
Yes, sir.
Okay, I was teaching grade 12 about 2 weeks ago, and something that all of them miss out is equal chords. So if we have two chords that are equal, like what I'm going to draw right now, and then you construct angles. So I have an angle called X. Can you see that? Sorry, I'm messing this up. But if that touch the circle, so equal chords produce equal angles at the circumference. Have you heard of that? Yes. No.
Yes,
Maybe.
sir.
Sorry.
Yes, sir.
Right. You heard of that. Very good. My diagram is very looking very untidy there. Okay. So remember, equal chords produce equal angles. And the last one, before we get onto this, I think we should cover this, is what we call angles in the same segment. Looks like a bow tie or a butterfly. All right. So if that's X, that's X. That's Y, that's Y. Angles in the same segment are equal. And with that, we're ready to get into some questions. It's very difficult to teach geometry. My apologies, I should have given you a hard copy so you could have been working with me, but we're going to try. So there's our first question. The figure below, RDS is a tangent. So keyword, tangent. If BC is equal to DC, immediately if two sides are equal, I'm getting what we call an isosceles triangle. They gave us that D1 or CDS is 40 degrees. Calculate with reasons BDC. So if we look into the diagram, we are trying to find this angle called D2. So if I'm working this question out, I like to use a backward philosophy. If I'm trying to find B2, my first question I ask myself is, what is D2 actually equal to? Anybody knows?
B1's
B1. What's your reason there, young man?
equal angles, opposite equal sides.
Angle,
Angles equals opposite equal sides.
angles opposite equal sides, all right? Angles opposite equal sides. Now, what is B1 equal to?
40, sir.
Why?
D1.
Thank God.
Well done. So we can see now that B1 is equal to D1 tan chord theorem. And then we get our 40 degrees. And if B1 is 40, then we come up to D2 to be 40 degrees. And our reason there is sides, angles, opposite equal sides. Is that making sense to you? So, next one. BDC, I said is 40 isosceles. There's no mark for that. So I wanted to write that down and tell you that angle is not accepted. Anyone who writes isosceles triangles use a mark. The reason we're looking is for angles opposite equal sides. Okay. Now, my next question was to find angle C. Well, that's quite simple. To find angle C, we can use some angles of a triangle. 180 degrees. 180 minus 40. So we have a triangle here, which is adding up to 180. So 180 minus 40 gives me 100 degrees. Now I'm trying to find A. Let's stop and breathe. How would I find angle A?
Cyclic quad.
Ooh, that was quick. And somebody saw a cyclic quad. Can everyone else see the cyclic quad? I'm drawing it in there. There's our cyclic quad. 4 points touching a circle. And opposite angle C is A. So we're going to use 180 minus 100. And our reason there would be cyclic quad. Well done. We now go to O1. How would we find O1?
Angle at center is equal to 2 times the angle at circumference.
Well done. You're seeing the link. So O1 is 160. And that reason there would be angle at the center. That's a good opening question for us, all right? Okay, let me give you some time to think before we get into this question. All right, I hope you read the question. So the first thing I'm seeing is ST is parallel to. So as soon as I see parallel lines, racing to my brain is alternate angles, corresponding angles, co-interior angles. Then I see a keyword PQR, tangent, so tan chord theorem. And it carries on, and then they tell us two angles, W1 and Q3. Now that's given information, is 30 degrees. So our first question is to find angle V. Any takers? How would I find angle V?
So you can say S1 is 30 because of Alton. I don't mind.
Okay, gentlemen, I want to teach you, technique is very important, not answers. If you're trying to find V, always work on a backward process. So can I find an angle related to V or equal to V? So can you see, I see a cyclic quad. Can you see that? So we know V and S1 will be supplementary. Can you see? I'm looking at that cyclic quad. But then I asked my question, okay, I found a link there. Now let's work. What angle is equal to S1? So you'll notice you got parallel lines.
W1.
So S1 and W1 are alternate angles. Well done. So there I have it now. So now we can move front. So it means I'm going to find S1 first. And S1 is 70 degrees, alternate angles. Look at the parallel lines. Can you see that? I got the Z coming in there. And then from there, I can conclude that V is 110. There's a cyclic quad. You can highlight it. Oh, sorry, it's on a computer. All right, I should highlight it for you. So this is a cyclic quad we're looking at. And the opposite angles are supplementary. Okay, Q1. How do we find Q1? Any takers?
So could we say that Q1 is equal to 70, sir?
Reason. Give me a reason.
Tan chord theorem.
Well done. So can you see the angle between the tangent and the chord? There's the chord we're looking at. So from this chord, we have an angle in the circumference. So from the chord SQ. So that works well. Okay, so we got our tan chord theorem. For those of you who cannot see it, there's our angle between the tangent and chord. And from this chord, we have an angle being produced at the circumference. Right, Q2. Any takers for Q2?
Some angles on a straight line, sir. So
Well
they're
done.
80.
Angles on a straight line give you 180. So all we're going to do is take 180. There's our straight angle there. 180 minus 70 minus 30. That should give us 80 degrees. Last one, T1.
Opposite
Opposite
angles of cyclic quad.
Well done. Opposite angles of a cyclic quad. I hope you guys saw that cyclic quad. Let's draw it for people who cannot see it. Okay, this is the cyclic quad we're talking about. It's coming up in blue. Okay, so if that's 80, 180 minus 80 is 100 degrees, and that's because it's a cyclic quad.
So can we assume that that's a cyclic quad, sir?
Why are you gonna, what you mean assume? It's touching the four points in the circle.
Oh, I see. Never mind.
I'm not making an assumption. I am making a mathematical decision based on the facts I see in front of me. All right. So we can't make an assumption, but that is a fact. 4 points touching a circle produces a cyclic quad. All right. This is a nice question. Go for it. Let's see what you do. Digest, make a note of keywords. Technique is very important. Keyword I'm seeing always a center. All right, very important. If O is a center, immediately, what can we conclude? We have radii coming out from there. Which means,
Triangle OCO.
well done. So remember, we're trying to find O1, but before I find O1, let me find C1 because I can work with an isosceles triangle. So we can say C1 is X, angles opposite equal sides. And from there, I can come out with 180 minus 2X, some angles of a triangle. What will angle A be? Anybody worked at angle A?
So it'll be
2
90
times
minus
180 minus 2x.
You see, it's said in terms of X, so we're not trying to find a value numerical. We're trying to find something in terms of X, all right? So what did you guys get?
90 minus x. So
90 minus X, we're dividing by 2. Okay? So we're going to divide that 180 divided by 2 is 90, and 2X divided by 2 is X. And that's how we get a 90 minus X up. Last question, D.
So it's a cyclic quad, sir.
Well done. We see a cyclic quad. So if it's a cyclic quad, what will the answer be? Do some algebra, okay? 180 minus 90 is 90. Negative and negative gives you a plus X. So we end up with D to be 90 plus X. All right, we're only doing calculation questions. We're going to come now just now to some proofs. All right, let's look at this one. Oh, they should be telling us that O is the center. They missed that out. O is the center of the circle. All right. Give you some time to read. So the first question here is to find PQ. Anybody knows how long PQ is?
So if the,
24,
Sorry?
24, sir. 24 centimeters.
How did you get 24, young man?
So because there's a radius and a chord going across, therefore the two halves of the chord should be equal. So 12 plus 12 is 24.
So what's your reason?
So, so the one with the radius and the chord, so
So that's what you're gonna write on Monday, the one with the radius.
the angle is center.
Hey, grade 11s are taking a chance. Okay, I'm talking from a grade 12 perspective. I would give you 0 if you don't have a proper reason. What reason am I looking for?
Line from center perpendicular to chord.
That's what I'm looking for. Line from center is perpendicular to the chord. That's what we're looking for, because that line from the center, because it's perpendicular, it's bisecting that chord and giving you a 12, 12. So in actual fact, maybe we should have found PT first to be 12, as that will be our reason for PT. And from there, we can come out with PQ to be 24. So once again, reasons must be stated properly. Wrong reason, not going to get the mark. Next question, we want to find PR. Four marks. It means you need to do some thinking here.
So we have to find OT first, and we can do
Oh.
that by using Pythag.
Well done. Somebody said, let's go find OT. So if we're going to find OT, let's get into OT. And you use a lovely word there, Pythagoras, all right? Can everyone see that right angle triangle? Take your calculators out. 13 squared minus 12 squared should give me 25. The square root of 25 is 5. Okay, so we're going to find OT. Let me write how this needs to be written. So our OT, you could say, is 5. You could show the calculation, but basically we're looking for a reason called Pythagoras. I'm skipping the working, all right? Now, how is that going to help us?
So because now OR is a radius, which means it's also equal to 13. And then 13 minus 5 will give us that part there, TR. So yes.
They're absolutely brilliant, absolutely brilliant. So can you see the radius that he's talking about? If that's 13, then OR has to be 13. And then we can use into the blue triangle, remember, that's also 90. So we can use Pythagoras and we can find PR, 12 squared plus 8 squared, which will give me 144 plus 64. And then we can square root that. What do we get there? Anybody know?
14.42.
Sorry?
14.42.
14.42. Someone to check that, please. I don't have a calculator on me, all right? So, very interesting how you had to break up this question. They didn't tell you to break it up. You had to slowly get into Pythagoras and bring it in. All right. I think we should skip now. We've done enough of that kind of questions, right? So I want to get into something a little bit more challenging now. I'm going to open another PowerPoint. Okay, what are you seeing now?
So we're seeing question 8.
Very well done. That's what I want you to see. Right. In the diagram below, the circle having center O. So we see they gave us a center O. So immediately you're thinking like me now. Hope I have indoctrinated you how to think here, or else we got a problem. Oh, my pen is playing games with me now. Let me just end this show and restart it. All right. I hope you're still seeing question 8. It says, we have a center called O. Now, immediately if I see a center called O, I'm thinking angle at the center, I'm thinking radii. I got an isosceles triangle. And it goes on to tell me lots of things. Then I see a word called tangent. Then I'm also thinking now, maybe I can apply tan chord theorem. I saw this word center. Then I'm seeing parallel lines. I'm thinking alternate angles, etc. But anyway, let's get to the question. The question wants to know, what is D1? Anyone knows? What is D1?
Angle at center
So
two times angle at circumference.
Ish, that was quick, man. What angle at the center is twice angle at the circumference. Well done. Did you guys see that? So it's talking about an angle at the center because it's formed from the 2 points, the chord AB. From AB, we also got D1, and that's how he's getting 65 degrees. Actually, I should let my PowerPoint do that. 65 degrees. Are you happy with that? Well done. What is B1?
So it B1 equal G1, sir.
Why? I just want to know why.
Tan chord, sir.
Well done. B1, tan chord. There's a chord. Angle between tangent and chord is producing D. So we have the tan chord in existence. BAD, bad. Can we get BAD out? Some of you are singing Silent Night now. BAD.
alternate angles, sir. So it's 65.
Well done, young man. I had to draw it in because some people were not seeing it. And you see alternate angles, the lines are parallel. Did you see that? So we're looking for alternate angles. Going to angle C.
Opposite sides of a cyclic chord.
Cyclic quad. Well done. 180 minus 65. B3.
So you can do some angles of a triangle because G2 is 90.
How do you know G2 is 90?
Because angle from center is perpendicular to a chord.
Did they tell us it's perpendicular? Did they tell us the midpoint?
Oh, no, they didn't, sir.
So we know that angle B4 and B5 is 65, sir, because of alternate angles. And then the whole of B3, 4, and 5 will equal 90, sir, because it's a radius and a tangent, sir.
Well done. Can we just put that into exactly what is being said there? So we don't have to actually find it then. What we can do is make a simple statement here. See, we have a radius. From the center, we have a radius that is perpendicular to a tangent. So we can conclude that this angle is actually 90 degrees. Oh, sorry, I'm trying to find B3, not B2. My apologies. Let's take that out. Then the young man is totally right. We're going to go to his hint, which was said very nicely. So we know this whole angle, a radius is perpendicular to a tangent. That whole angle is 90. But because of our beautiful Z that is there, some of you would not see the Z. Let's draw it in. B4 and 5 would have to be 65 degrees. It's alternate angles. And therefore we can take 90 minus 65 will give us 25. Are we happy with that? Does that make sense now? Okay. Okay, I'm not going to do 8.26 because the question is missing, so we'll skip that for now. Okay, go a little deeper now. Okay, let's read this question. KOL is a diameter. KOL of the circle. R is a point on the chord such that KR is equal to RO. KR is equal to RO. So we see a lovely isosceles triangle there. Chord KM by 6 means to cut into equal halves. So LKN. Let me find LKN, which means K1 is equal to K2. That's what this bisect means. K1 equal to K2. Okay, let's start the question. So the first thing we can say K2 is equal to X. And the reason why is it's underlined KM by 6 LKN. We don't know what the question is yet, all right? We're coming to the question. Okay, I missed the question. I should have told you what the question was. Can we just go back? Okay, my diagram is messed up here. Okay, I think we're trying to find. I'll have to go front just to pick up that question quickly. Okay. Okay, we're going to skip that question because I can't find the question. It went, something's wrong with my PowerPoint now. I don't see the questions, okay? Let me just end the show. I need to see why they're not pitching up. Okay. My apologies for that. I'm going to open a document that was given to all grade 11s. I hope you received this document. All right, they gave you past paper questions. Do we have a hard copy? Do we all have this copy? Yes, no, maybe.
No, sir.
Ooh, okay, I'm going to post this onto the groups later. Unfortunately, we need it now. It's not going to get to you in time. I thought all grade 11s were given this past paper questions organized by topics. You never got this? Yes, no, maybe.
Not a hard copy, sir.
You got a hard copy. Well done. So you
No,
were
that's
given
what
this
I'm saying, I
document.
don't.
Sorry?
I'm saying I don't have one.
You don't have. What about the other guys? Did everyone get? No one got this document.
We did, sir.
Well done. Maybe it's on your team's group. Maybe you missed it. All right. So we're going to look at this document and we're going to try and work some questions out from this document. Are you happy with that? I was hoping you had a hard copy, so it would have been easy for you to work. So I'm actually sitting on page 63 now. Okay. But if you don't have a hard copy for now, we'll have to work together. Okay, let's start. In the figure, O is the center of the circle. As you can see. So we got a very important word. That word that we're looking for is center. All right, and it goes on and then it says, okay, we have equal in length. AB and chord DC are equal, so we have equal chords. All right, so the first question there is to find angle O1. And then we're going to find
78.
angle O2. Help me out. What is O1 equal to?
78.
Why? Why is O1 equal to 78, young man?
Angle in center is 2 times the angle at circumference.
Well done. Angle at the center is twice from the same 2 points. We got that. So we got our 78 there. The next question there is to find O2. Help me out. What is O2?
So O2 is also 78.
Why is O2 78?
Equal chords, equal angles, sir.
Well done. Not vertically opposite now. Huh? Equal chords produce equal angles at the center. Okay? Equal chords produce equal angles at the center. They produce equal angles at the circumference. They also produce it at the center. I can actually prove it to you very quickly if you don't believe me. If you actually look at this, this is radii. So that. And what do we have? We have two triangles. Okay. Which are congruent basically, side, side, side. And therefore O1 could be equal to O2 using congruency. But we know in grade 11, equal chords produce equal angles at the center. So that was a good one to revise, equal chords. Okay. I'm going to skip some and get to the other ones. Can you see? This one says, prove the theorem for a cycle. In the diagram below, O is the center of the circle, and that is a cyclic quad. There's no question on that. So let's skip it and let's come here. 3 marks. Sorry. Okay. I want you to read this question and let's get into it. Give you some time to read. All right, we're ready to start. So the first question here, it says, QS and PR are diameters. Very important word there, diameter. The diameter talks about an angle in a semicircle. So just to let you know, so keyword, diameter. Actually, let me just change the color. All right. So we have a center O.
So I think you've gone mute, sir.
All right, sorry about that. All right, so when it talks about two diameters, as you can see, QS and PR. So if you know QS is a diameter, immediately you know this angle here is 90 degrees. Would you agree with that? Angle in a semicircle. If PR is a diameter, then we know that angle S, that angle there is 90 degrees. And then they also tell us that Q1 is equal to Q2. So our first question, just to get you started, to find Q1. How would we find Q1?
10 chords. Sir.
10
Oh.
chords.
No,
Where's the 10?
yes.
So,
Exterior cyclic quad.
Exterior angle of a cyclic quad. Ish, that's a good one. Somebody saw that very quickly. Let's quickly draw the cyclic quad that you're talking about. So 1, 2, Okay, that's a cyclic what he's talking about. He saw it very well. Well done. If that's 48 degrees, we know that the whole angle here is 48 degrees. Is that what you're telling me, young man?
Yes.
But it also tells us if we read the top, n is a point such that Q1 is equal to Q2. Can you see that? So if the whole thing is 48, each one should be 24. And there we found our Q1. We're now going to find angle R. Let me give you some time to think.
Sorry, sir. So how did you get angle Q to equal 48, sir?
Good question, young man. Exterior angle of a cyclic quad, you saw this 48? That's the outside angle of the cyclic quad is equal to the interior opposite angle. That makes
Yes, sir.
sense.
Yes, sir.
All right, anyone's got an answer for angle R?
So 24.
So Q1 is equal to R, angles in the same segment, therefore
Okay, I got some answers. Sorry, I didn't hear you properly. I just want to get this. So if we look at this diagram, I'm going to take out some stuff here because it's a little bit overloaded. All right, so we can see it clearly. And I think somebody said angles in the same segment. Am I right?
yes, sir.
So I just want to draw it in. All right. So when you see that angle there, it should be equal to this angle called R, giving you 24 degrees. All right. All right, we're trying to find M1 next. Let's go for M1. All right, anyone came up with M1?
It's 48 degrees for the corresponding angles.
Hey, well done. Somebody saw the corresponding. Hard to see because you're not working on a diagram. Once again, I must apologize. It's very hard to see. So I just want to draw it in there. So can you see that angle there? And M1 are corresponding. We've got the F shape. So we can now say that this angle here is 48 degrees. Corresponding angles. Let's go to the next one. Prove that, I like this question now. Now we're getting a little deeper. Prove that ST is a tangent to the circle passing to M, N, and S. How do you prove that?
So we can say that Q is equal to 24, sir. I mean,
Q.
48, sorry, sir.
Yes, carry on,
The
carry
whole-
on.
And surely if the whole of Q is equal to 48, sir, then we can say S1 is equal to Q. And then surely that would prove that it's tangent to.
You totally missed the mark, young man. You're totally off the question. Okay. Now, why would I say something? It sounds like I'm being so mean. All right, but actually I'm not. I'm just trying to state a fact. You're not reading the question. We're looking at MNS. So let's draw it in. There's our MNS. Can you see that? And we are trying to prove that ST is a tangent. There's ST here. So we're not interested in this point called Q. It's got no resemblance to what we're trying to prove. You're getting it?
So
Okay.
can you say tan code here?
Yes. Now, so the way to think about a question like this is if ST was a tangent, that's how you got to think this one. We're trying to prove it's a tangent. It's not a tangent. But if it was a tangent, then the tan chord theorem should hold true. That means if S1 is equal to M1, that is now showing you that the angle between the tangent, the chord, and this line ST is equal to the angle produced by that chord. So that means we are basically using the converse of the tan chord theorem. So if ST was a tangent, I must be able to show that S1 is equal to M1. So it's actually proven, am I right? So how are we going to write that out? So you would say S1 is equal to 48, given. M1 is equal to 48, proved above. Therefore, S1 is equal to M1. Okay? Therefore, we can copy and paste. When I say copy and paste, therefore, you'll say exactly that. ST is a tangent to the circle. And your reason would be, we are using tan chord. But whenever you prove it's a tangent, we're actually using the converse. So you put the word converse on the top. And that will give you your full marks. Anyone wants to
So
comment
do
on
you
that?
have to prove it through MN and S? Yeah?
Yes, we have to use MNS. Okay, because that's what the question is saying. There's a circle. What the question is basically trying to tell you is basically show that there's a circle passing through those 3 points. You understand? And because your tan chord theorem is existing here, therefore there has to be a circle and there's a ST will become the tangent. Let's do a little more. Let's do a little more. So we get into this little more proofs, I think. Proof. I like this word proof. As soon as we see proof, remember now we're going to a higher level questions, right? Okay. It's giving me a dual screen. I don't want to see a dual screen. Okay. All right, let's look at this question. Is it too small or can you see that? Yes, no, is the diagram clear?
We can see it, sir.
All right, let's go for it. It says O is the center of the larger circle. Make a note, O is the center. Let's put a dot there. It's a little bit too big, the dot. Okay, so if that's the center of the big circle, it goes on to tell us QP is a diameter. I can't find QP. Am I missing something? Oh, sorry, it's saying OP. OP is a diameter of the smaller circle, which means immediately we can go and mark this angle here to be 90 degrees. NP is a tangent to both the circles. So we have a lovely tangent there. Then RN is perpendicular to, on a line of word, tangent, perpendicular, diameter, and O is the center. Okay, question 1. Prove that PR bisects ORN. ORN. Okay, so basically we want to prove that R1 is equal to R2. Now they're not equal. We need to prove that. So where do we start?
So R1 is equal to 90 minus X, some angles of a triangle.
Well done. Go slowly, young man. Slowly, slowly. All right, we need everyone to catch this because they don't have a hard copy in front of them. So he's finding using some angles of a triangle. I like what he's done. Now, just to tell you, this is what you need to learn as a grade 11 student. If one angle is 90 and this angle is X, 180 minus 90 is 90. So the last angle will always be 90 minus X. And that's what he's using here for R1. Well done. Okay, carry on, young man. You're doing well.
So then T2 is also 90 minus X
Let me take
because of tan perpendicular to radius.
T2 you took me. It took me across there now.
So P2, sir.
P2. Okay, sorry. It's telling me that P2. Now let's quickly verify that. You see, they told us that OP is a diameter. Remember, I told you in the beginning that the diameter radius is perpendicular to a tangent. So there he's got his 90 there. Is that what you're telling me, young man?
Yes, sir.
Which makes this 90 minus X.
Yes, sir.
But they told us
since
O is a center. Carry on. You're doing well. Carry on.
So since OP and OR are equal since they're radii,
Those are radii.
then P2, so then P2 and R2 are equal because of angles opposite equal sides.
Well done.
Therefore,
5 marks.
R1 is equal to R2.
Well done. Good 5 marks, the gents. Very happy with that one. That one went well. Let's see what the second part of that question say. Prove that ROS so they're saying prove that ROS is equal to PAT. Okay, so let's mark it just that we know what is happening. All right. So I'm going to just use a color here. They're telling us to prove that ROS, that's that angle, should be equal to PAT, P-A-T. So we're trying to prove that. They're not equal, but that's the way I'm going. All right, for 5 marks. That's a lot of marks. It means you got to do a lot of thinking. Any takers? Give you some time to think. Okay, let's spend some time looking at it and pondering over it before we come together. Let me give you a 2-minute. I'm going to go on mute for the next 2 minutes while you think. All right, any takers?
So P2 and P3 are equal to 90 degrees.
Well done. Angle in a semicircle.
Yes, sir. And since P1 and P2 is 90 minus x, and P2 and P3 are 90, then P3 would be equal to x.
Carry on.
So, and because of that, Q2 would be 90 minus x.
Carry on.
And then since that's the Q1, okay,
So can we say that angle PAT is also equal to 90 minus x because of the cyclic quad? So
Why would it be 90 minus x?
well, if it's 180 minus 90 minus x, so
Yeah, I don't want to give you that. Should give you a 90 plus x then.
so since Q2 is 90 minus x, and P2 is also 90 minus x, then QS and RP, they are parallel.
Ish, you're taking me to parallelize that. Okay, let's go a little bit more simpler. All right, let's go a little bit more simpler here, guys. So let's follow me in my thinking here. Right, firstly, we see we have I have a problem. You see we have a tangent. Can everyone see this tangent? And isn't it angle equal to x? Yes or no? So you can conclude the tan chord theorem. Can we conclude that T1 is x? If you wanted to find T1. Yes or no?
Yes, you can, sir.
Yes, sir.
And God.
Then the whole angle of T then be X, so not just T1. So
No, this is the chord RP.
Tan chord theorem, sir.
Tan chord theorem.
okay, so
Remember that's a radii. So if T1 is x, which is the other angle equal to x?
P3, sir.
Well done. Now you're seeing something. So what will O1 be? Exterior angle of a triangle. Wouldn't O1 be 2x?
Yes, sir.
Yes, no, maybe, maybe.
Yes, sir.
Are you sure? You're looking a little confused. Agreeing with me, not agreeing with me, disagreeing?
We agree, sir.
Well done. Somebody's agreeing with me now, okay? So, parallel lines, that would actually work very nicely. Corresponding angles. That could have solved half my problem. But I don't know if you saw it. The young man was trying to tell me about a cyclic quad there. There's the cyclic quad. Can anyone see this big cyclic quad? So he was trying to tell me that A and R, I said it's supplementary. So if you want to find A, you've got to do some algebra. So angle A is actually equal to 180 minus 90 minus x. And if you work that out algebraically, 180 minus 90 is 90, but a minus and a minus gives you a plus x, which means angle A is 90 plus x. You with me? Yes, no,
Yes, sir.
maybe.
Yes, sir.
Okay,
Can
so
you
we found,
repeat that, sir?
sorry,
So
May you please repeat that, sir?
Okay, we're using the cyclic quad. Let's go back now. We're using the cyclic quad. I wanna take that lines out so you can see it, okay? I'm gonna highlight the cyclic quad I want you to see, okay? Isn't that a cyclic quad?
Yes, sir.
So what do we know about opposite angles of a cyclic quad? They are supplementary. Agreed. So it means angle A and R must give us 180. So if we have angle R, so we just have to say 180 minus angle R. This is angle R. Should give you what we're looking for is angle A. And that's how we got A to be. And that's PAT. So we got PAT. PAT is 90 plus X. Yes or no?
Yes, sir.
All we have to do now is find ROS. Now, ROS is made up of Q1 and Q2. Already found Q1. What is Q1?
True, sir.
2x.
It's O1. Sorry, I'm saying the wrong thing. That's O1. What is O1? 2x. Now, who can tell me what's O2?
So it's 90 minus 8.
90 minus 8.
Hey, 90 minus x. You saw the triangle. Well done. We got some intelligent guys here. 90 minus x. Are you happy with that?
Yes, sir.
Now, what is Q1 plus Q2, which is ROS? Now, let's work out what is ROS. ROS is made up of Q1, which is 2x, and Q2, which is 90 minus x. Let's do some algebra here. What will we end up with? 90, what's 2x minus x plus x? Isn't that now equal to that?
Yes, sir.
Let's take some time to digest that. Yes, no, are we happy? Have I proved it? Gentlemen, have I proved it?
Yes, sir.
Okay. A little bit of a toughie, because remember, these are proving questions. Whenever we're dealing with proving, we're looking at a level 3, all right? We're not now on a level 2. So I think I'm quite happy with that. I'm just scrolling to look at some lovely diagrams here. Oh, this one looks complicated. Sure. Says prove it's a cyclic quad. Some nice questions here. Fine, give reasons, prove that PS. Well done, some good questions here. I'm just scrolling. Okay, I'll take one question now. 2 circles intersecting. Okay. All right, time doesn't permit us to do everything, but we're trying to do some, okay? Are you happy with that? Beautiful questions. Prove the following. I think this is a good proof question. We're going to do this one, all right? So I'm going to give you 3 minutes to read the question. All right. I hope you had some time to read. It says EA is a tangent, keyword. Let's go and look at EA. Tan chord theorem is screaming out to some of us. Okay, let's look at it. Let's now apply the first one. If EA is a tangent, just want to draw it for you. So there's our first thing, tan chord theorem. So which angle will be equal to A1?
C2.
C2. Can everyone see that? There's the chord. And from the chord, you draw a triangle. and the point touching it is the angle we're referring to. Are we all happy with that? So we got C2 to be X. Well done. Let's read the question. A1 is equal to X and Y is equal to, E1 is Y. So our first question is to prove that BCG, no, it can't be BCG. Oh yeah, it's a line. BCG must be parallel to AE. So if you're trying to prove, I'm trying to prove converse. So I'm looking for alternate angles. If the alternate angles are equal, the lines have to be parallel. If the corresponding angles are equal, the lines have to be parallel. So we're going to start off by highlighting those two lines. So we're going to prove these two lines are parallel. So we're going to look for some alternate angles. If they're equal, the lines will be parallel, could be corresponding. So if I look into the diagram now, as you can see, anything coming to your brain before we go on?
So you can, since they say that AC is also a tangent, sir, you can use tan chord theorem and prove that G2 is also equal to X, sir, which makes it alternate to A1, sir. Or G2 is equal to X, sir, because of tan chord theorem.
So that guy read the question properly. It also told you AC is a tangent. If AC is a tangent, well said, young man. If AC is a tangent, as you can see, then that angle there we're looking for, let's change our color. Then this is the angle between the tangent and the chord. If that's the tangent, there's the chord. And it's going to produce a lovely angle for us called X there. And now you can see that G2 is equal to A1, but those are alternate angles. And if the alternate angles are equal, then the lines have to be parallel. Now that's a 5-mark question. Let's try and write that out. Okay. So what I did first was I found, how am I going to get 5 marks here in an examination? Because the teachers for geometry mark very, very strict. Okay. And if your reason is wrong, if your opening statement is wrong, there's no part marks, we stop marking. That's why paper 2 is such a difficult paper, all right? If your first statement is wrong, then we stop marking your question for 5 marks. There's no method marks, okay? So, opening statement. We're going to say C2 is equal to X, and you need a reason. So I'm not going to write down, I'm going to tell you. That was tan chord. Okay? Or if you want to be a little more precise, you could have said C2 equal to A1, which is equal to X, tan chord. Then we're going to say G2 is equal to C2, which is equal to X. Once again, tan chord. Therefore, we're coming to a very important point. A1 is equal to G2, which is equal to X. That's a conclusion. Now, that's a very key statement. Therefore, we can copy the statement. BCG is parallel to AE, and the reason is alternate angles equal, converse, you can put. Because the alternate angles are equal, the lines have to be parallel. So that's how we can get 5 marks. Next question, we got to prove that AE is a tangent to circle FED. So what you got to do in an exam, we want to highlight FED. That's what I want to start off by doing. So I know what I'm proving. So there's my F. Okay. And the line that we want it to be a tangent there is AE. So AE. Now, if AE was a tangent, then E1 should have been equal to F1. Can everyone see that? Now, E1 is Y. Can I prove F1 to be Y? a little bit too thick, this line, and we're blocking the angles. So I want to draw it with a, rather with a pen.
But sir, can you say E1 equals C3? Oh,
Be with you just now, young man. So we got FED and we're trying to say AE. AE must be the tangent. Yes, let's go for it. What you want to say?
so E1 equals C3.
E1. I'm trying to find E1 is equal to C3. Why? Give me a reason.
Alternate angles.
Well done. We're following you. That's a good point you're making.
Then so can you say C3 equals F1 exterior angles of the cyclic quad?
You proved it, man. That was a quick proof. Well done, young man. So if you haven't followed his proof, looks like we got some good problem solvers in grade 11. So following the reasoning behind that, so first thing you told us that angle C3 is equal to angle E1, which is equal to Y, and our reason there is equal alternate angles, because we finished proof these lines parallel, okay? And you could have said GB parallel to EA. Then you went out to tell us a very important point, and those of you who haven't seen that, let me draw it for you. He found a cyclic quad. And this is a cyclic quad this young man is looking at. That's a cyclic quad, and he said, right, F1 is actually equal to C3, which is equal to Y, exterior angle of a cyclic quad. And our closing statement, which we're trying to get to, is therefore E1 is equal to F1. Very important point. And therefore, copy the question down. Therefore, AE is a tangent to the circle. And your reason for that would be tan chord theorem, but you're proving. So remember, put the word converse on top. Good one. Getting there. Last one. We want to prove AB is equal to AC. Let's look for AB and AC. Now, basically, if you want to prove AB is equal to AC, the quickest way to do that in geometry is to prove that the angles will be equal, because sides opposite equal angles will be equal. In other words, we're trying to prove an isosceles triangle. Simple as that, okay? So let's look at that. They told us AB and AC. Okay, that's a triangle. So if we can find angle B and angle C1, and if they're equal, then we know that that's an isosceles triangle. AC has to be equal to AB. So let's go and find the angles. Can we find C1? Anyone knows what C1 is?
180 minus X plus Y.
180 minus X minus Y, or 180 minus X plus Y. Angles on a straight line. Well done. So we need to find B. We know B has to be 180 minus X plus Y. How can we get it back?
So we can say angle A1 plus A2 is 180 minus X plus Y.
Carry on.
And therefore, angle B will also be 180 minus X plus Y because of tan chord theorem.
Tan chord theorem. Did you guys see that? That was a quick one you saw. Huh? I hope the rest of you saw it. Okay, what he's trying to tell you.
That's A2 is equal to Y though.
A2 is equal to? Why is A2 equal to Y? I'm listening to you, you're not giving me an answer. Why would you say A2?
I'm asking how are we able to do that, so then?
Okay, right. Let me explain that, right? What this young man saw is this. Okay, gonna get quite interesting, this one. So having a diagram to show you is very important. So look at this triangle here. I'm drawing in. We're gonna use some angles of a triangle. If we use some angles of a triangle, it allows us to find this angle A1 and 2. Remember, C2 is X, E1 is Y. So therefore, this whole angle here is actually 180. Let me get some space here, sorry. Okay, so this whole angle here is 180 using some angles of a triangle, 180 minus X plus Y. Does that make sense?
Yes, sir.
Right. Now, there's a tan. This is the tangent. Remember, that's a tangent. That's a chord. So this angle here, because of tan chord theorem, will be equal to this angle, which is now 180 minus X plus Y. Got it?
Yes, sir.
And therefore, because these two angles are equal, therefore the sides will be equal, and the reason will be sides opposite equal angles. Okay, so that was a good question, which allowed us to do some proving. 15 marks, 14 marks. Okay, gentlemen, I'm going to stop there and now allow you to carry on. You see, geometry, I wasn't doing a lot of work, to be honest. I wanted it to come from you, and the answers were coming through because it's a thinking process. All right. I just needed to see how you guys were thinking, and let's be honest, most of the time you're coming up with answers, so it was good revision. Okay. Any questions before we close? All right, no questions. Good night. You can carry on studying.
Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.